Hey guys, I'm Pat Kelly. Okay, in this problem, they're asking us to find the area of the triangle with the indicated vertices. So they have these 3 points in 3 space that they've given us. And actually, to get started, what I'd like to do, even just as a matter of bookkeeping, let's get some names on these points, A and B and C, only so that you and I are talking the same language here as I start my work, because one of the first things I want to do is find vector AB. So you'll see which 2 points I'm referring to. Now what you should be asking me is why? Why are you finding this vector? And the reason is, part of the lesson that we just learned is that you can use the cross product of 2 vectors if they represent the adjacent sides of a triangle to find the area of the triangle. What we do is find the cross product, find the magnitude of that cross product, and then take a half of that. And that's going to be our answer. So that's the work we're going to do, but I need to start by getting these vectors. Now, you've done this kind of work before, where if I want to write this as a vector, grab your second point, your terminal point of B, and subtract component-wise, so a -2, and subtract the component up here in the A point. So -2 subtract 2 looks like a -4. Now, as I'm writing these, I'm going to write them in component form. So I'll start my triangular brace and then just put some commas in between. And let's keep going. So now I'm looking at a -2, subtract 3, so -5. Comma, 0, subtract a -5, so that'll bump up to a +5. And I'm done with that vector. Now I also need a vector for the adjacent side, which is going to be AC for me. And I'll do the same kind of work where I'm looking at C as the terminal point. 3 take away 2 is just 1. 0 take away 3, -3. And then 6 take away a -5, so I'm up to 11. And that would be my component form for that vector. All right. Now I like those in front of me, because then I'm going to come over here and find the cross product between them. So now I'm looking to do some work for AB cross AC. And I already addressed the y, but just to refresh your memory, the cross product of these, then I will get a vector. I need the magnitude of that vector, then I'll take a half of it, and we're going to have our answer. Now we've also been learning the cross product in this lesson. And the cross product, one of the best ways to calculate it is with this determinant form, where what we have is the I vector, the J vector, and the K vector written as the top row. And then your other 2 rows of this will be these components. So I'm just going to go from left to right. -4, -5, 5. And then the bottom row, these components. 1, -3, and 11. Okay. So this will equal, I think I have some space here, make sure this fits. We do this work by doing your cofactor expansion type of work for a determinant. So for my I vector, my submatrix will look like -5, 5, and -3, 11. I'll need the determinant of that. Minus, that's part of your cofactor work, is the J part has a minus sign in front. And then your submatrix this time is going to be -4, 5, this 1, and then that 11. And then we'll finish with a plus. I need my K part, where my submatrix is going to look like this, the -4, the -5, and then the 1 and -3. Okay, that step is implementing that cofactor expansion. Now you do the dirty work and actually calculate this, which is mostly arithmetic, right? So this equals, the arithmetic then is doing these determinants of the small 2x2s. You do your crisscross pattern. So I'm looking at a -55, and I'm subtracting. The 5 times -3 is -15, so it's going to be a +15. That'll be my I component, minus parentheses, And my crisscross here looks like a minus 44. Subtract 5. That'll be my j component. Plus crisscross here looks like a positive 12. Negative 4 times negative 3. Subtract a negative 5, so I'll make that plus 5. And that'll be my k component. And so this cross product, I'm still working with my cross product, that will equal, do some arithmetic as I promised, minus 40i. This looks like it's going to be a negative 49 inside, but there's a minus sign outside, so let's write plus 49j, and then a plus 17k. Should have warned you up front. I'll warn you now. Grab a calculator if you need it. I'm going to need it in a minute. But back to what our process here was, is that we found the cross product of two adjacent sides of the triangle. Now I need the magnitude. So my next step is to find the magnitude of AB cross AC, which you know the formula is the square root of each of these components but squared and then added together. So a negative 40 I'm going to have to square, a 49 I'm going to have to square, and a 17 I'm going to have to square. I'm going to add all those up and then take the square root of that. And that's where I'm going to defer to a calculator for that. Okay? Grab a calculator. And let's see. Looking at negative 40 squared plus 49 squared plus 17 squared, and I need the square root of all that. Square root. Looks like that will be approximately equal to 65.5. I round. Okay, that's good. And back to our process, we said that the area of the original triangle we're looking for will equal half of that. So we need 1/2 of that magnitude that we just found. AB cross AC, which means, I'm still holding on to my calculator, I'm just going to take half of that 65.5. So 65.5 divided by 2. Approximately, I did round at one point, correct? Approximately equal to 32.75. It's 32.75, okay? And for good measure, let's put some units on here. Since this is an area, I'll say square units. All right, there we go. Try some on your own.